study the velocity, speed, displacement, also the average and instantaneous velocity, average and instantaneous acceleration. Now we are moving to our next point, which is Newton's law. The Sir Isaac Newton derived three important laws. So we see the step by step. So there is Newton's first law. Before going to the statement of your first law, we are considering one small example. Just consider a duster which is kept on this wood. Now we just check the duster will be at the rest. So now I am just here I am applying the force horizontally. If I will apply the force will be if which is greater than your frictional force. Now where it is frictional force? The frictional force which is observed the interface between this block and the duster. So in between here we can observe the frictional force. So if your frictional force will be greater than this frictional force, then this duster will be having in motion, or you can say that the duster will be accelerated. So now I am applying the force, just pushes at the one end of that duster. We can see that. So by applying the force, the duster will be in the motion, or we can say accelerated, changing their position from this end up to here. So we can see that if my force which is greater than the frictional force, this duster will be accelerated. Now just consider here the frictional force will be more. If we considering just on that surface of that block, we consider just put at the wax or make this surface will be smooth. So if you make this surface will be very smooth. So in that case we see that if you apply same force, just like a previous force, if I apply the same force, the displacement or the motion will be changes, which will be increases. So for the same force, the object, this duster, move more distance, it covered the more distance, so you get a longer distance. So just because here your frictional force become less, your surface will be very smooth, so in that case this movement occur a longer distance. So even you just pull it or you just pushes this duster, you get the motion. Before the Galileo, all the scientists felt that every particle or object, the natural state of matter will be rest. All scientists consider that the natural thing, the state of that all the matters having it is at the rest. So or just consider any sliding object which will be stopped just because there is no any force. There is no any force to stop that particle. One thing is the natural state observed in the nature will be at the rest, and any sliding object will be stopped just because of there is no any other force to stop these things. Also in later on the Galileo who say that the object will be stopped or this thing will be changed just because of the nature will be resist or opposed to that particles. Galileo says that these things happen because of the nature will be resist or opposed to that system. In the last, the Sir Isaac Newton formalized this all those things and they state the Newton first law. So now we are moving to our main statement of Newton's law. Here Sir Isaac Newton says that every inanimate body, our statement is every inanimate body is in its state of rest. It is at the rest or it will be in the motion. It will be in the motion in a straight line unless it is acted upon by the any external force. What the Newton's first law says that every inanimate body will be at the rest or it will be in the motion in a straight line unless it is acted by any external force. Any external force. So here the Newton's first law which states that every inanimate body continue in its state of rest. Continue in its state of rest, or if it is in a moving or of uniform motion in a straight line, which is in the uniform motion in the straight line, unless it is acted upon by some external force. If it is in the motion, in the uniform motion, so unless it is acted by some external force to change their state. So simply we can say that if any object which is at the rest position or which is continuously uniform motion, so if you want to change their state which is at the rest or it at the motion, so that requires the external force. So we can say that every inanimate body continue in the state of rest or uniform motion in a straight line unless it is acted upon by some external force, and that force which is required for to change their state. It may be your rest position or it may be a uniform motion which is in the straight line. In the simple term we can explain if any object, just I have explained here, in that case your duster will be at rest position, or if any object which is continuously moving, so to change their uniform motion we need some external force to change their state. So here in that case their acceleration will be changes or their velocity will also be changes. Now in a previous section we study about the inertia, and inertia also states that the inertia which is nothing but which is resist or opposed to change of state. Inertia states that which is resist or I can say oppose to change of states. So here we can say that, here also we say that the uranium body which continue in a state of rest, continue to the state of rest or uniform motion in the state motion of straight line unless it is acted by some external force. So here also to change their state you need external force, and here it will be resist or oppose to change their state. So because of that your first law of motion also known as the law of inertia, or we can say that called the law of inertia. Law of from this term or this simple statement you clear the all thing about your Newton's first law. In our Newton's first law, again we just consider a small example. Just consider a table. On that table we kept a tablecloth, and that tablecloth we just put one small dish. Now just do one small thing. Suddenly just push this tablecloth, so we observe that the dish will not disturb. If you suddenly push this tablecloth, so in that case your dish will be on that table. So just this happened just because of the inertia. Your dish will be at the rest, and due to the inertia the dish will not disturb. only you, if you pushing this tablecloth, in that case this as it is in the rest position. So if you considering in that case as overall forces acting on that body, here in your first Newton law, if you considering the forces, overall forces, so the average forces, if this average forces is equal to 0, consider any object and on that object the forces acted on it, which this average, if the average forces are 0, then you can say that this body, it will be at the rest when your average forces is 0. So you can say that this body is at the rest position, or it may be a moving position in a uniform moving state. So this state, if you want to change this state, you need some external force. To change this state, you need some external force. So this is F1, F2, F3 and F4. So if you considering this vector sum of all the forces, let's say F is equal to F1 plus F2 plus F3 plus F4, and this overall sum, if it is 0, it will be rest or in uniform motion. Uniform motion. Now, in that case, there is another term which is balanced force and unbalanced force. So, if you consider it, taking a small example again, you know the tug and war, in that game, if there is a balanced force, there will be no result. If there is an unbalanced force, in that case, the more extra forces in that side, if you using the more forces, so this team will be winner. So you just consider a block, and on that block there will be two forces acting on it, F1 and F2. Just consider it is a car, and on that car you are acting a 100 Newton force, and in the same manner you are using from this front side and back side same force. So here you can see that in that car you are using 100 Newton from the back side, 100 Newton from the front side. So here you can see that there is a balanced equal force in a opposite direction. Here you are using equal force in opposite direction. In that case, this object is in a rest position. It will be not changing because you are using a equal force in a opposite direction. So here it may be in a rest, so it may be a rest, or if it is in the moving, in the uniform motion, so it will be in the uniform motion because you are using equal force in opposite direction. If it is different, now we just consider here from the front side the force will be 40 nanometer, and from this side you are using 100 Newton. So from this side you are using more or larger force. So in that case here there is a unequal force in again opposite direction. You are considering in opposite direction, but here the force will be unequal force. So from this side you are using a maximum force. If you consider comparing with this force, the F2 will be more. So we observe that this object which is moving in this direction. Just because of these higher forces, this F2 will be higher as compared to F1. So the object is moving in backward direction. If this force will be 400, again this is unequal force. This F1 is greater than your F2. So in that case, this object changing their states, which is at the rest, this changing their rest, and which is this motion object in the forward direction or a positive direction. So there are two cases. In first cases, if you apply the equal force in opposite direction, then there the system will be in the rest position or continue uniform motion. You can say that there is a balance force. If it is in a equal force in opposite direction, and if it is unequal force in opposite direction, then you can say that it is unbalanced force. So this is two examples for balanced and unbalanced force. So using these two concepts, your first law of motion is depend on the balanced and unbalanced forces. Here we again consider one small example, the object weighing. So in that, you know that your object which is suspended to this spring. I think in your home there is this old weighing pan. So in that, you know that here we can suspended your object to this spring, and this springs gives us the exact weight of that your object. Basically here there is a small phenomena which is, or here you are using our first Newton law. So we can consider this object. This object is exerted the gravitational force. This gravitational force basically in a downward direction. Your Fg, which is in a downward direction, and here your force, spring force, which is exerted. Basically this spring force gives us a exact weight of your this object, and this Fs, this here I explain the Fs which is exerted in the upward direction. Your gravitational force which is acted on this object and which is in the downward direction. Your force spring or spring force which is exerted on the upward direction. Here I have mentioned the upward direction. Now you know that in your Newton first law says that the average sum. Here at this stage your object at the rest position. Here your object at the rest position. So your acceleration will be 0. Here your acceleration will be 0. So you know that the average sum of that forces also 0. So you can say that f of g minus f of s which is equal to 0. Here I have mentioned the negative sign because the Fg exerted downward direction, Fs in the upward direction. So your Fg minus Fs which is equal to 0. So you can write Fg equal to f of es. So whatever the gravitational force existed on your object, which is nothing but your force, spring force, or the exact weight of your object. So this relation gives us the exact weight of this object, which is in the rest position, and if it is a rest position, their acceleration 0, or the average sum of the forces is also 0. And from that you get Fg is equal to F of S, which is nothing but we tell us that the exerted force, which is a gravitational force, equal to your spring force, and this gives us the exact